the star motor that you have on the screen, is composed by the motor, the solenoid, the fork, the pinion bendix, and the brushes. In other words, the star motor is basically a DC motor, high torque motor, and a solenoid. If you check the slide that you have on the screen right now, this is the typical connection for a star motor in a boat. You have the star motor receives the main power from the crank relay, and the crank relay receives the main power from the a.c.r and battery bank, and the crank relay is activated. The coil of the crank relay is activated from the ignition position in the ignition switch, and the solenoid on the star motor is activated with a signal coming from the start position from the ignition switch. The color of that signal is yellow-red. In other words, the star motor is a DC motor. Let me explain quickly how a DC motor works. Okay, if I have an alternator, I have electromagnets in the rotor and coil on the stator, and I produce electricity. Now I am going to explain the motor. This is an alternator or generator. Electromagnets in the rotor and coils on the stator. Okay, what happened? Suppose that this is the positive side of one magnet, and this is the negative side of other magnet. What happened when I have the positive and the negative pretty close? In one moment they attract, and the positive attract the negative, because this is the law of the magnetic elements. What happens if I have two positives pretty close? What happens when the positive magnet is practically in front of the other one? You can touch? No, they repel. What happens if I have electromagnets in the rotor and permanent magnets on the stator? What happens in the moment that one positive is in front of other positive, or one negative in front of other negative? The rotor spin, and the other one spin, and start the motor. What happens when the positive is in front of the negative and you power it? You bring the brushes here and you power the rotor, and immediately you power the rotor starts to spin at high speed. The star motor have the motor, the winding, the solenoid. The solenoid receives the input power coming from the crank relay. The power passes through the second terminal, and from the second terminal enter into the winding of the motor. The power passes from this point through this point only when the signal is coming. The signal is a yellow-red signal coming from the start position on the ignition switch. For example, in this moment I don't have power here because the crank relay is open. I am going to close the crank relay, and right now I have power, but I don't have power in the second terminal because I don't have signal. When I bring the signal, immediately I have power. The gap is closed and the power passes through the second side and the motor starts. This is the relay. The relay receives the power here from the batteries. In this moment I have power here coming from the battery. That's the power. But I don't have power in the output because I don't have signal. The signal is coming from the purple signal ignition. When I close ignition, I have power here and I have power here, and of course the power passes through the other side. I have power here. Off, no power here, no signal, I only have power in the first position. I have power on the signal, but I don't have power here. Probably the solenoid is damaged. In that case, you need to replace the solenoid. Other important and common problem is the start motor, the ground is not appropriated. The ground should be connected directly to the ground bus bar or directly to the negative of the battery. The ground on the start motor is critical. The ground should be located on the case of the motor. Never, my friends, never try to connect the ground in other terminal here on the solenoid. On the solenoid, you only have big positive and signal. Never try to put a ground on the solenoid. Be careful when you tight those terminals, because this is plastic, this is bakelite. If you torque too much, you destroyed the solenoid and you ruin the start motor.